And I think after I go over these 3.9 questions, I think that'll pretty much get most of the questions that are kind of, you know, these three today, they're good questions. So let me see how many we got. 18. 1, 2, 3, 4. Still got 15. 15 videos and 19 people. So 1, 2, 3, 4. Now we got 16 and 19 people. So we still got 2 or 3 people who don't have the videos on. So I'd appreciate it if you turn your videos on, please. All right. Oh my gosh, Mr. Rodriguez, we don't have a ceiling today. You are it today. I appreciate it. Thank you.
I'm at work right now, so I have to keep like bouncing up and out.
Well, I appreciate you being a part. All right. So here we go. Here's the questions that we got. Let's see. One is 3.9. Let's see, I want to do that one first. Let me find the first ones. Because somebody sent a couple. I got them from several. Here we go. I'll just write this one down. This is like 3.9, 79, 20. 3.9, 79, 20. And I'm just going to write it down for you. 3.9, 79, 20. Well, you sent me those 3.11 questions, but I'll go over those tomorrow. Okay, there's the question right there, and here's the question that somebody sent me. Now, I think we've went over one like this, but I may be wrong. F of x is equal to 10x to the natural log of 10x. Okay? So the first thing I would probably do is I would change that to y, and I would take the natural log of both sides. That's what I would do. So go ahead and try that. Change it to y and take the natural log of both sides. And then once you get it down to a simplified algebra problem, so that'd be y is equal to 10x natural log of 10x. Now take the natural log of both sides. Natural log of y is equal to the natural log of 10x, natural log of 10x. Okay, now you should see something now with the logarithm properties. Look at the logarithm properties right here. Can anybody tell me what kind of logarithm property I can use right here? Not the product rule, but the
chain rule.
Power rule. There's not a chain rule in logarithms. So I'm going to bring this out front. Natural log of 10x times the natural log of 10x.
Because they have the same base, can't you just make it 10x?
No, you've got, I know what you're talking about. The property that you're talking about has to do with this base. If this was a 10 up here, yes, you could do that. But no, not natural log.
Well, aren't they both?
I know what you're talking about.
Because what? It's natural log e to the 10x.
I'm sorry, say again?
Well, because natural log, its base is e. So it's natural log e of 10x. And
The
then
LOGE of 10x. Natural log is log to the base e. But I know what you're talking about, but no, you cannot do that with the natural log here. Now, if this was 10, you could do that. If this was just 10x, you could do that. But since it's natural log, you got to bring it out. Now, what is this? What is natural log of 10x times the natural log of 10x? Natural log of 10x to the what power? To the second power. Now you can rewrite that, but that 2 is going to come out. So go ahead and take the derivative of both sides. Take the derivative of both sides. So implicit differentiation, I'll give you this one, 1 over y times y prime is equal to 2 log of 10x to the first power, 2 log of 10x to the first power, times, what is the derivative of the log of 10x? 1 over 10x, and then the derivative of what's inside is 10. Now, the people that sent me this problem, they didn't do this last part right here. Remember, this is 10x. This is in parentheses. This is in parentheses. And then this is in parentheses. So you've got not only to take the natural log of the derivative of the natural log of 10x, you've got to take the natural log of 10x derivative, and then you got to take the derivative of what's inside. And this right here is the part that people leave off. That's the part they leave off right there. And now it's just cleaning it up because you've done the calculus. Now you just have to solve for y prime. So I'm going to let y'all do that. So go ahead and finish that up. I'll write it on the next page. One over y prime is equal to, well, that's going to just come down to, let's see, 10 over 10x is left with 1 over x. 1 over x times 2 be 2 over x times natural log of 10x. I don't know what that was. Is that somebody's phone?
Oh, I did not know I was not on mute.
That's all right. And now I'm going to multiply by get my orange pen. I'm going to multiply through by y over 1. And that's going to give me y prime is equal to y times 2 over x natural log of 10x. And somebody tell me what y is from the beginning of the problem. That's all right. I'll do it.
Y is 10x
10x
to
the natural log of 10x. Yes.
Yeah.
Times 2 over x natural log of 10x. Now, you could actually take that to the 2 over x power. You could rewrite it, but that's good enough for me. So I'm going to just there. Let's see, where's my, yeah. There's that. And then there's the, well, that's not, here it is, I'm sorry. There's that. I'm just putting it up there so if you watch the video, you can pause it for the one person that's going to watch the video. And there's the finished part. Could be a test question. I usually don't put a lot of long questions. This is considered long, especially with all these natural logs. I don't usually put a lot of those. I might put a couple, but not a lot. All right, let's do a nerd. Let's do this one. 3.9 85/21. Find the derivative of 1 plus 3 over x to the x power. Now, I'm going to tell you right now, not a lot of people can do this problem. Okay, do you know why? Because everybody's stupid, that's why. No, because there is an exponential law that not a lot of people remember, and I'm going to write it in red because you need to remember it after today because you might see it again, and that is a to the b can be rewritten as e to the b natural log of a. Now, it's not one that you use a lot, but I can tell you right now, if I was to ask y'all, there's how many in here right now? There's 21, 23. I can't believe there's 23 people in here. Come on, people, turn on your videos. I'll turn on mine. I'm not going to be a hypocrite. Turn on your freaking videos. Good God, you can't communicate. At least you can turn on your videos. God. I mean, why don't we just do this? Why don't we all just sit in a freaking black room and just not talk? How about that? Some of y'all would be perfect. Good God. You won't talk, you won't get on and then when you get out in the real world, when you fall flat on your face, just remember I told you, you need to freaking communicate. Good God. All right, I'm sorry. I have to deal with it with the first class. I have to deal with it with this class. I'll just drink water. Yeah, whatever. All right, so I've got this right here, A to the B. A to the B. So you need to rewrite A to the B as this right here. So do that. So we're going to take the derivative of E. Okay, B is X. So that's going to be X natural log of A, which is this. So X times the natural log of 1 plus 3 over X. Now, the good thing about E is the derivative of E to the X is E to the X. But in this case, this is chain rule and product rule. There's the product rule right there. So you're going to have to, so this is going to, so the derivative is going to be this, because this is E to the X. The derivative of E to something is E to something. So E to the X times natural log of 1 plus 3 over X multiplied by what's inside. Let me take my pink marker. And this right here is what's inside. And how am I going to take the derivative of this? Use the what rule? Product rule. So that's going to be the first times the derivative of the second. Let me get my green pen and my orange pen. Times the derivative of the second plus the second times the derivative of the first. All right, now we're going to take it over to the next page. This, you just carry this down because this just goes down. You know, I'm not going to worry about this. I want you to work on this. So carry it over to the next page, and I want you to take the derivative of those two right there and start simplifying it. 1, 2, 3, 4, 13, 14, 15, 16. So we still got 6 people that won't turn their videos on. I was talking to a teacher the other day. Teaching's getting to where it's just to be discouraging. Not because people are stupid, because they won't communicate. Used to be because they were stupid. Natural log of 1 plus 3 over X. Some damn phones is what it is. And that's going to be X. Natural log of 1 plus 3 over X. Plus natural log of 1 plus 3 over X times the derivative of X. Okay, so I'm switching it over to the other paper now, and there's what we're dealt with. And our derivatives come out to be, I'm going to rewrite this, e to the x, natural log, oh shit, I knew I'd mess that up, natural log of 1 plus 3 over x, and the derivative of the natural log of something is 1 over that something. And then you have to take the derivative of that something. What's inside? Plus the natural log of 1 plus 3 over x times 1. Now, at this point, people usually quit, if they even get to this point, because at this point, they're saying, I don't even know what to do after I do this part. And then some people, before they get to this part, are saying, I don't even know how to get to that part. So I would say probably out of 20 students, probably 18 of y'all probably would have quit by now. So e to the x, natural log of 1 plus 3 over x. I just keep rewriting that over. And now I'm going x, and that's 1 plus 3 over x. And now I'm taking the derivative of this guy, which I can rewrite this. I'm going to rewrite it right up under here. 1 plus 3x to the negative 1. And that's going to give me a negative 3x to the negative 2 plus natural log of 1 plus 3 over x. So I'm going to rewrite everything now. So that's going to be e to the x, natural log of 1 plus 3 over x. That x and that negative 3, let's see, this is negative 3. So I'm just going to do this first. That's going to be x over 1 plus 3 over x times negative 3 over x squared plus natural log of 1 plus 3 over x. Okay, so we got to clean this up. So I need everybody to clean this one up right here. And actually this goes outside big brackets right here. So clean this up and see what you come up with. Algebra, this is nothing but algebra right here. Well, we got 18 now. 18 out of 24. There's still 6 people that haven't got their videos on. What I should do is kick them out of the class. What I should do. Oh, there's only one, which technically nobody should have an excuse, because I told y'all at the beginning of the semester that everybody should have their videos on. I told you that at the beginning of the semester. It just pisses me off when people can't. I'm about ready to quit writing this outside, because every time I write it wrong. All right, this right here, this x, I'm going to multiply by x over 1 over x over 1. I'm going to multiply that through the whole thing. That's going to give me an x squared on the top over x plus 3 times negative 3 over x squared. And all this trash, I'm just going to put a squiggly line right there. Plus natural log of 1 plus 3 over x. And the x squareds cancel. And I'm just going to write the final answer that's good enough for me. E to the x natural log of 1 plus 3 over x times negative 3 over x plus 3 plus the natural log of 1 plus 3 over x. And like I told you before, the first page right there, that's the algebra. I meant the calculus right there. And then that's all, well, you got a little bit of calculus right there. Most of it's algebra. All right, where's that last question? I had one more question. Let me see if I can find it. And that was like, old MacDonald had a farm. A-E-I-O-U. There it is. 3.934/10. F of y is equal to e to the y times y to the e. And of course, you're going to use your product rule. So, and everything's in terms of y, so you're not going to use implicit differentiation. You're just going to do the product rule. So go to it. I want everybody to try it first. Anybody want to take a stab at why people sent this question in? Anybody want to take a stab at it? I'll give you a hint. It's not because of the calculus.
Ease.
I'll give you a hint. It's not because of the calculus.
It's because they're poor at algebra.
Because of the algebra. And they don't turn on their videos. I'm just kidding. I just want to know what some of y'all are going to do when you have a problem at work. You're going to go hide in the janitorial closet. Hide and don't say anything. Turn your videos off and don't say anything. There's some people going to get fired. F prime of y is equal to first times the derivative of the second plus the second times the derivative of the first. Another reason students get confused on this problem is they know that the derivative of e to the y is e to the y. That's not a problem. It's this one right here that gets them. They don't know what to do with it. So we'll just go ahead and quit after we write this one down. After we write here, you throw your pencil down and quit. Make it pop. You know how to make it pop? Y'all probably don't even get mad. This generation don't get mad. They don't talk. They don't turn their videos on. What do y'all do?
Can't imagine much.
What?
I said I can't imagine much.
I don't understand what they do. I came up in the 80s, and the 80s was like the 60s. We were rebellious. You say rebellious now, you get hate speech if you say rebellious. 60s and the 80s were a lot alike. At least we had the best music and the best movies. Nothing. Not one damn thing.
What movies did y'all have?
I could say anything in this class, and nobody say a damn thing.
What movies did y'all have?
Oh, all of them.
Rambo.
I mean, you got the Rambo movies, you got the Rocky movies, you got, oh my gosh, there was a lot of them. I can't even name, don't even mention Jason and Michael Myers. I mean, we had all of them. And then we had the best music. You had the hair bands. Oh man, they were great.
They also had.
What would you say?
And nobody, Guns N' Roses, nobody can beat Guns N' Roses. Well, maybe AC/DC, you know.
What was your
That's
favorite?
some of the best music
horror
in
movie?
history.
What would you say is your favorite horror movie?
My favorite horror movie, I like Annabelle. I like Annabelle.
Annabelle is good.
I like the Conjuring movies and Annabelle. There's one movie called Mother. You ever seen that one? It's where the woman, the ghost comes back and steals the children. And that movie is creepy. Ouija movies. Oh, the Ring movies. Have you seen The Ring? Where the woman,
Yes.
where the girl climbs out of the well?
Yes.
That's scary movies. That's scary. Thank you for that little bit of conversation. I appreciate that. I know that hurt some of y'all a bunch, really. All right, e to the y. All right, watch what I do here. E times y, e minus 1. Basic power rule. Plus y to the e. And then the derivative of e to the y is e to the y. Okay, now technically, you're done with the calculus. But trying to get y'all to get this in a simplified form, that's what gets y'all on the test or the homework. So I'm going to rewrite it, and maybe it'll help you out a little bit the way I rewrite it to see if you can continue to simplify it. There you go. Now that should give you a hint. And right quick, let me ask you something. Let me go back to pre-algebra for a second. What's in common there?
Be an
The
X.
X's.
So x to the first you would factor out, right? So would you say that you always factor out the lowest exponent? Would you say that? When you factor out an exponent, do you always go with the lowest degree exponent when you factor it out?
Yes.
You do. Thank you. So make sure you factor out the lowest exponent. Somebody tell me what you think we can factor out here.
Y to the E.
Well, e to the y is in common. You were supposed to say that first, but that's okay. I'm going to factor that out. And which one is the lowest between e minus 1 and e plus 0? Which one's the lowest?
E minus 1.
E minus 1. So you're going to factor out an e minus 1 there. And a lot of you are going to go, you're going to go, I don't know how to do that. Well, you know how to do it because you know how to subtract fractions. You divide when you factor, right? Let's go back to pre-algebra. Don't you just do this right here? Don't you do this when you factor? You do this in your head and then you write down the answer. Don't you do that? Yes, Hubert, that's what we do. Yes, that's what you do. So we're going to divide, which means you're going to subtract exponents. You're going to subtract exponents. So let's go back here. E to the y, e minus 1. That leaves e plus, well, that's going to be 1. And this right here is going to be y to the e plus 0 divided by y to the e minus 1. And we subtract exponents, right? So f prime of y is equal e to the y, e to the minus 1, e plus 1, and then this is going to be y to the e plus 0 minus e plus 1. And somebody tell me what happens to the e's.
They cancel.
And y to the first power is y. So the final answer, and that's what people were having trouble with, getting to the final answer. The final answer for this problem is f prime of y is equal to e to the y, e minus 1 to the e plus y. So the problem on this one that was sent to me was not the calculus. The problem with the student sending me this one was the algebra right here. They couldn't figure out how to get a y here. And that's the 3.9 questions that were sent to me. And yesterday's video was on 3.11. So that leaves 3.10. Now 3.10 is not a big deal. A lot of plugging and chugging. Did y'all get this? Did y'all get this before class?
Yes, sir.
put this with your other notes. This is something that you need to put on an index card. Plug and chug. Whatever this x is, you plug in right here. But I'm going to show you how we get the first one at least. Let's see. Hold on, I'm getting my other notes. This is how you get, now I'm just going to show you one derivation. What do you mean? I'm going to show you how we go from here to here. I'm going to show you one of them. I'm not going to show you all of them, because that's just going to take a lot of time. So the derivative, find the derivative of the inverse sine. Let me get my handy dandy whiteboard up. Y is equal to the inverse sine of x. And the inverse sine is between -1 and 1. That just comes with it. Do y'all remember a while back in algebra? Let me get off of this for a second. Y is equal to x squared minus 2. How do I find the inverse of this function algebraically? We did this in the review. How do you find the inverse of this function?
You switch the x and the y and
Switch
solve for
the
y.
x and the y, and then what? Solve for what?
Y.
Okay. Does everybody remember that? Everybody remember that, right? I hope everybody's saying yes, because y'all
Yes, sir.
can't even shake your head up and down. So, because that's communication and y'all can't do that. So, all right. So if I want to find the inverse of this function right here, I just switch to what?
The x and the y.
So the regular function of this guy is x is equal to the sine of y. Okay, and I'm showing you how to get the actual inverse. And sine of y, that's between -pi/2 and pi/2. Now, if I took the derivative of this, if I took the derivative of the function, so this is the inverse function, I just switched y and x, and it became a regular function. Then that would be 1 is equal to cosine of y dy dx, or y prime, and then 1 over cosine of y is equal to dy dx. And using the Pythagorean theorem, we know that cosine squared plus sine squared is equal to 1. Therefore, cosine is equal to positive or negative square root of 1 minus sine squared y. We've got cosine, we got that. We know that x is equal to sine, so we can say this is x. So that would be cosine is equal to positive or negative square root of 1 minus x squared. So if cosine, so therefore we can take this and that would be 1 over positive or negative square root of 1 minus x squared is equal to dy over dx. And that's how we get from there to this with your derivatives. Now, the reason it's positive is because you can't take the square root of a negative. So that's why this is positive. It's always going to be the positive. Okay, so that's why, that's how you get all 6 of these. Now, I'm not going to go through each derivation, okay? But that's basically how you get all 6 of these 1 over square root, negative 1 over square root, 1 over that, negative 1 over that, 1 over absolute value, negative 1 over absolute value. That's how you get those. So this is one of those times where I want you to, trust me and say, okay, we understand, even though you won't say anything because y'all don't communicate. So here is an example of a problem you will see on my test. Find an equation, sorry. Find an equation of the line tangent to the graph f of x is equal to the inverse cosine of x squared at the point 1 over square root of 2, comma, pi over 3. Now, I'm going to highlight this point right here because this right here is in the x spot. That right there is in the x spot. So I'm going to highlight it because I'm fixing to plug it into this guy right here. So let me take my handy dandy pencil. I'm fixing to put it in that guy right there. Stupid mouse. Oh, damn Russians. Let me try that again. Now, how did I know to pick this one? Well, it says cosine, the inverse cosine. I mean, I'm not going to pick the cotangent when the question says inverse cosine. Do y'all think I should do that? I don't think so. So I'm picking the inverse cosine, and here's what I'm going to plug it into. Right there. Now remember, this is 1. What if I've got something else there? Well, you've got to take the derivative of what's inside. Don't forget. So I'm going to clear this out. And I'm going to go back to my whiteboard and get rid of that. So I'm going to plug it into f prime of x of the inverse cosine is negative 1 over the square root of 1 minus x squared. Well, what's in my x squared spot? Well, what's in my x spot? X squared. So I'm going to plug and chug. -1 over the square root of 1 minus x squared times, what's the derivative of what's inside? You got parentheses here.
2x.
What's the derivative of x squared?
2x.
And I'm going to put that in orange so you will remember. Take the derivative of what's inside. Now clean this up and you got your equation for your slope. That's it. That's how you take the antiderivative of an inverse trig function. Plug and chug. You will see these in Calc 2. You will see these. F prime of x is equal to -1 over square root of 1 minus x to the 4th times 2x. -2x over 1 minus x to the 4th square root. So that is the equation for the slope of the tangent line at any point on this curve. So somebody
Good
tell me
question.
the slope at 1 over square root of 2. You got plug and chug. So go ahead and do that.
Hubert, quick question.
Yeah.
Why did you leave the radical on the bottom? Why didn't you bring it like to the top?
When you're dealing with the inverse trig functions, they stay like that. That's why I showed you. That's why I showed you the derivation. Okay, you don't conjugate.
Okay, I just want to make sure.
You don't conjugate the derivative. Okay, you leave the radical on the bottom.
Okay.
So I'm going to go to the next page. And I'm going to rewrite my formula down. F prime of x is equal to -2x over the square root of 1 minus x to the 4th. And also, Mr. Michelle, I'm not simplifying this. I'm solving it. I'm plugging in something. So when you plug in something, you're going to end up taking the square root of a number. So, and you only get rid of when you're solving, when you're simplifying an expression, you're not solving it. You're just simplifying it. We're solving. So f prime of, what is that? 1 over the square root of 2 is equal to -2, 1 over square root of 2 over the square root of 1 minus 1 over the square root of 2 to the 4th power. All right, simplify this. Give y'all a minute to do that.
Priority 1 message coming in on secured channel.
It'll be -2 over the square root of 2 over the square root of 1 minus 1 to the 4th power is 1. The square root of 2 to the 4th power, I'm going to write that out. Square root of 2 times square root of 2 times square root of 2 times square root of 2. Now, a lot of you saying, really, you're going to write that out? Well, the reason I'm doing that is because some of y'all say that the square root of 2 to the 4th power, y'all say that it's like 16 or something, or I'm not sorry, 81 or something. I don't know why y'all do that. And that's going to be negative 2 over the square root of 2 divided by the square root of 1 minus 1 over, well, the square root of 2 and square root of 2 is square root of 4. Square root of 4. And what do we get? 1 minus 1/4. And that's going to equal negative 2 over the square root of 2 divided by the square root of 3 over what? 4. And that's going to be negative 2 over the square root of 2 divided by the square root of 3 over 2. And you divide a fraction by another fraction, you multiply by the what?
Reciprocal.
Reciprocal. So that's going to be negative 2 over square root of 2 multiplied by 2 over the square root of 3. So our slope is equal to negative 4 over the square root of 6. Now, if you wanted to change that into 4 times the square root of 6 over 6 and then reduce it down, that's fine. But remember, our final, we're plugging and chugging here. So it really doesn't matter if you reduce or what, you're still going to end up plugging and chugging, and it'll end up reducing before long. Okay, so now we have a slope, a point, 1 square root of 2 pi over 3, and we've got a slope. What happens when we have a point and a slope?
You use the point slope equation.
There you go. Mr. Michelle, you know you're not supposed to answer. Y minus y sub 1 is equal to m times x minus x sub 1. All right, knock yourself out. Go ahead and plug and chug. Look at all those fractions. I just quit. Miss Seiler looks like she's quitting already. Look at her.
Hubert,
Can't
could
do
you
all
just
those
show
fractions.
could you just show the previous page?
No,
With the
let's see. You're talking about, let's see, where was I? Hold on, what'd I do with it? Here it is. This is it. Talking about that one?
yeah, that one. Okay, that's okay. Thank you, Hubert.
So y minus pi over 3 is equal to negative 4 over square root of 6 times x minus 1 over square root of 2. Oh yeah, I'd quit. Y minus pi over 3 is equal to negative 4 over square root of 6 times x minus 1 over square root of 2. All right, that's going to be y minus pi over 3 is equal to negative 4 over square root of 6x minus, be a plus, 4 over square root of 12. And then y is equal to negative 4 over the square root of 6x plus 4 over the square root of 12 plus pi over 3. And we could try to manipulate this a little bit. I would multiply this by the square root of 6 over the square root of 6. And that would give us negative 4 square root of 6 over 6x plus 4 over square root of 4 square root of 3 plus pi over 3. And that's going to be negative 2/3. Let's see, square root of 6x. And that's going to be 2. And 4 divided by 2, that's going to be 2 over square root of 3. 2 square root of 3 over 3 plus pi over 3. So y is equal to negative 2 square root of 6 over 3x plus 2 square root of 3 plus pi over 3. And I would take either one of these answers. I mean, that's just kind of reducing it down. I don't really think you could. No, that's about it. At least I got the common denominator. Now, let me rephrase. What did you do on this problem? Well, here's the problem. There's the problem right there. You took the derivative using plug and chug from your card right here. You used that one right there. You found x. Which one is x? X is right here. That's the x spot. So if this was x to the 3rd, then this would be x to the 6th, and this would be 3x. Okay, so whatever this is right here, it's going to go there. It's going to go there. And that's the derivative. And then you got that, plugged in the x, and got a slope. Take that slope, with that point, plug and chug. Now that's the type of question I'm going to ask you on the trig, on the inverse trig functions. We'll probably do another one tomorrow, probably one from the homework and one off the test. Okay, that's enough for today. Y'all's brain is frying. I can smell it from here. Doing all those fractions. Y'all, a lot of y'all can't do those fractions like that. Got to reach for a calculator. Let me look and see if we need to check the attendance. Oh, God. Hold on a minute. Let me pull up from. Oh, this is so stupid. ETC. Sorry, let me cut off the recording.